Nice to meet you. Today's topic is related with second stage of the training with Stag 400.
That's right, and welcome once again, Marcin and Tomek, and we'll continue with Stag 400 DPI.
Exactly. Last time we finished the basic information related to application and how system works, and some informations like a first step information related with the auto calibration, and then we want to start today with the application with explanation of some functionalities of Stag 400. So let's follow the screen related to application, please, and we'll finish the application settings.
Right. When we will find out some more advanced features, some difference between our direct injection and controllers that are working with direct injection and indirect injection, we also would like to present to you some information on the flip chart to understand what for or when we can use one or another option, right?
Yes, exactly. So follow the application information on the screen. What we are seeing now, so if it was last time informated that this is a place when we choose the engine, yes, type of the engine, standard, turbo, then there is some information related to the source of the RPM, right. The divider and the voltage of the signal. At the next stage, and there is information about petrol injection reading, because after montage we have some additional parameters to explain it, what's the reason and how it works on the practical way, yes, how it's related with the readings, because in some engines we need to a little bit modified. Why? Because of the firmware in the petrol ECU, even the code is existing. Sometimes the different firmware in the petrol ECU is also have an influence on the petrol steering signal. So in these cases, when we are meeting after connecting the application first time, and we will see unstable readings, or the readings is sometimes even not available, we can see right. the zero, yes. First step, what you should do is to modify these two parameters. One is injection signal gain, and another one is pulse level, and the last is pulse filter. I think let's go to the chart to explain the reason of existing these two parameters.
Okay.
So what you can see here on this graph, there is a current in petrol injection steering. There is a steering voltage signal, the green line, and the supply voltage, the blue line. And because we need to start reading from here, so no matter which one signal it is, this is the start of the reading, yes? And this is an end of impulse. So we can read it like a F. This is an example, like a 1.2 milliseconds, yes?
Yes, but and what the important thing, even if you measure this signal 1 milliseconds, just to remember that in our program we have the injection dose. So sometimes when you measure the signal with the oscilloscope, exactly. You can find out that there is a difference between this signal, the time of the injection,
exactly,
and then the time that you have in our software.
Yes. So
right. So
in reality, this time is opening of injector.
Right.
But in application, you can see the petrol dosage. Yes.
That's
but
right.
the petrol dosage is related, as we spoke the last time, it's related with the fuel pressure. That's why
right.
You can read sometimes higher value than 1.2 or lower than 1.2. But if this real opening time is 1.2, it means that it's a petrol opening time, but not the petrol dosage.
Right.
And okay. These two parameters, what we said in the application, one is a gain, and gain, we are meeting some problems with the gain with this small difference, because petrol ECU is steering the petrol injector. What we are seeing is the end results of the voltage, the green line, but we need to read from point to point, yes? And if we set the line of the reading, sometimes this green signal like can be like this,
right?
yes,
This is
and can be like this and like this. So that's why we need to miss some points to read properly. So this is a pulse level explanation, because pulse level is the moment when we are moving the this line up or down, depends on missing these points to reach out proper opening time, yes?
Right.
So we should, using movements of this line, voltage like we have from 0 to 5 volts, so we are trying to miss this small disturbance on the voltage line. And the gain, it's that sometimes this difference between this voltage, it means like this is 0 volts, yes, and then we have a very low like 5 volts, we need to add pull-up voltage additional, so this gain will add some extra extension of this graph, yes, so some of the lines will be down, much more down, and then it will allow us to extend this signal to be more flexible and more easy to read by gas ECU. So these two parameters, they are just helping us to make it easier to read the properly petrol timings.
That's right.
And then we'll show you in application how it's the results, for just an example in the real conditions a little bit later, how it works, yes. And these two graphs, as I said earlier, it's not so easy to read it, because this is a current, yes, so we should cut measure current. This is a voltage. Also, it's very difficulty to read the start and the end in these conditions, because also it's having some distortions. So we are basing on reading this impulse, and the reasons of moving the signal or extending the signal is just to find the proper petrol readings. That's all. So we can, I think, back to the application if Thomas don't have some additional information related to this.
No, because it's the information that Marcin told you is everything that we can tell you about the graphs. Now in the software we can show you when we can use or when we can need to use those two options, right?
And exactly. So just summarizing, normal signals should like this, but it's the situation when it's not existing in real life, because we are after conversion we are connecting our ECU. Our ECU is also making some small distortions, like can produce some small lines like this. And summarizing, we are using these two parameters to make better readings, right, because we are trying to miss these positions of these distortions to reading.
Right.
Readings, yes?
One of the parameter extends the range, and the second parameter find the
to change the line, yes, right, change of the line of the readings, yes, and then we can follow the application again.
Okay, right now we can try to simulate those two parameters: injection signal gain and injection pulse level. As you can see on the right side, right now we have the, let's say, normal reading or stable reading when we are talking about the injection dose, right? After the installation, normally just we need to say that if you have the car with the engine, and that engine has the code that exists in our list, that exists in our software, normally after auto calibration, those parameters, injection signal gain and injection pulse level, should be set automatically. Those are the information that we have in our software when you choose the proper engine code, right?
Exactly.
But sometimes there can be some changes in ECU. The producer of the car can change something in the ECU, and let's say
yes, the reason is that we are meeting some thresholds, voltage thresholds, and these voltage thresholds is occurring the reading. Like you can see now on injection dose, that the injection dose is very unstable. Yes, it's blinking from 0 to 1.2. Another cylinder is similar, and all of the rests. And in these situations, probably after montage, if we are seeing, and we are, of course, 100% sure about the connections are made properly, so we can follow the gain and the level, yes, pulse level reading, and then you can see what's happening. If I just raise up 0.2 voltage, it's stabilized, yes.
Right. So this is the situation with when we can go back to 2.0 voltage, right? Oh. Right now you have unstable. This is the situation that Marcin showed you on the flip chart. So the level of the reading can find out those distortions that we present on our flip chart.
Yes,
right?
This is a presentation of the effect what you can see in the car. Yes,
right.
This.
So that means that one thing you can do in this situation, move the pulse level, the injection pulse level a little bit higher, to avoid reading those distortions.
Exactly.
Right?
Yes.
So when we move a little bit higher the voltage, now the readings are fine because we change the level
of the reading.
Of the reading. So right now the system is reading stable injection time.
And sometimes also the voltage threshold from 0 to the opening voltage is so low, so that we need to extend it. In here in application, we cannot show you this effect because it's just possible in the car, not on the simulation machine. Yes, what we have here today. And another thing, what we can show you, maybe it's an injector pulse filter. Injector pulse filter. We didn't show you on the graph. It's something that another distortion at the end of the signal. We are meeting some small peak, voltage peak. Yes, it's related with inductive peak from the coil, and sometimes this inductive peak occurs just after the real signal, and is occurring jerkings during driving, and then we can turn on this pulse filter, and from our experience, it's often happening in 2.0 turbo Hyundai Group engines, Kia, and then you can see the effect that the ECU is cutting this additional impulse, just ignoring this signal and stabilizing the readings. Also, yes, much more suitable. Then let's follow another functionality. It's extra injection correction.
Right.
Because this is typical, this is like a voltage only information that what kind of voltage or current lambda are connected to the ECU.
Right, so right. This is the physical connection, right?
Yes,
the
exactly.
Physical connection.
And information about ECU that you connected or they are not connected. And another one parameter what I just start talking about, it's extra injection correction. Normally, if we have engine working without extra injection, this area is not filled by the yellow, yes,
right.
Like now it is. So if you are doing drive, we'll see that this yellow area is blinking or is constant, and then it's related with some small jerks.
Right.
Let's find out the OBD informations, how the mixture is rich in this moment. And then if you follow and connect informations that this is blinking or constant lighting on yellow, right. And then short theme is going minus, for an example minus, yes, if go minus, what we should do, we should reduce the slider on the left side and goes minus, and automatically we should see reaction on the petrol ECU. If we are seeing that is backing close to 0, so we can reduce even more and see it should be goes close to 0. It's mean, and it automatically the car should stop jerking, yes, in these situations. So this slider is helping you to reduce the petrol and the gas relation dosage instead of existing extra injections. Yes, that's why. And additional, if we will see during acceleration on some conditions during drive, this area is blinking on, is yellow, but short trim and long trim goes to plus. So we should go follow backing to slider right, yes, and then as you can see here, after meeting the 0, the slider goes to plus. These plus values should generate the effect of opposite side, but
right.
it just did it during. So summarizing, if we have extra injection, then we can observe the short trim, and if the short trim during extra injection goes minus, we move the slider on the left to minus side, right. Or if this short trim and long trim is going to be higher than normally conditions, it means it goes lean, so the end effect should be slider move to the right, yes, and it helps to prevent jerkings and helps to prevent occurring some extra injections in relation to overfueling or making too lean mixture, yes, in this situation. So that is a slider for extra injection handling.
Right. So summarizing those car parameters window, I think it's
yes,
all the information that we
all we need.
Right.
Yeah,
just only one thing, maybe you can also find out and consider trying to understand why. Normally, when you do the auto calibration, the injection signal gain and the injection pulse level are set automatically. And most of the cars, you can find out that injection signal gain is 35%, right? 35%. Yes. So, for example, like here we have the Mazda engine code, and when the injection signal gain will be set to 15%, that means everything is okay.
And that's what you said exactly. The default setting is 35, and here in Mazda is 15. And what you can reach, that if you connect the default settings the issue with default settings to Mazda, that's why you are getting the code of petrol injector circuit. Right. Because it's 35, this voltage is too high, and it occurs this situation when petrol ECU discovers open circuit injector, and the reason is that the gain voltage level is too high. That's why we need to reduce it. If you choose during auto calibration Mazda, these settings will follow down to 15, and then if you reset this error related to circuits of petrol injectors, it will never appear again. Yes, that's the reason. If after conversion you start the engine and then suddenly see the in Mazda check light on the dashboard, and if you read the errors is related with the petrol injector. Nothing is wrong. Just after auto calibration, everything will be fixed. Just don't forget to erase the errors. Nothing more.
Right. Okay.
Let's follow the next step, and the next step is gut control settings. And there is some data that last time we didn't talk about this. And what is it?
And it's very similar to our indirect petrol injection controllers. So just like in Q generation, as you can see on the first left side of the window, switch over to gas. So all the parameters are connected with switching to gas. On the right side, petrol switch over. So the parameters according to the switching to the petrol. Below you have the calibration parameters. Those parameters are set automatically after auto calibration. The only thing is just to check if the operational pressure is the same like the working pressure after auto calibration. And also we have the information about the gas injector type, reducer, temperature sensor, gas level indicator, just like in the Q generation, and the configuration of the OBD. The difference that we can find out are the intermediate phase during switch over to gas, and the intermediate phase during switching the petrol. As you can see here, when you open the window that you can change those parameters, there are 5 different parameters: very slow, slow, normal, fast, and very fast. And according to the name of these parameters, changing to gas and changing to petrol, will be faster or slower, right? So the intermediate phase, you choose the proper intermediate phase, you choose according to the sensibility or...
Yes, sometimes there is like a factor from the hoses of the injectors are longer than should be, and if you feel during this exchanging phase from petrol to gas or gas to petrol, some small jerks, so that's why you can edit these settings to make it more smooth or even not feelable, yes, like this. So this is like in QBox and GoFast, like a fewer overlapping situation, yes, when we can together choose how long both fuels existing in one cycle or more cycles in cylinder working.
Right. And according to your opinion or asked that or when we are talking with you during our conversations or our trainings, sometimes you asked us to add hot start options to the 400 DPI, and more engine codes will have that hot start options because more cars have the hot start option when
they're having stop start. They are having stop start systems. Yes, that's why we are added this functionality that you can decide to turn it on or turn it off. Depends on customer or demand on your decision on it.
Right. If you are in the gas control setting, the important information when you go to the gas injector type, then you switch that 3 dots. The gas injector setting open window will appear. Maybe I'll move it. It's close. Okay. The important information is about bank, right? You have bank 1 and bank 2. There are cars
even 4-cylinder with 2 banks.
With 2 banks, so this is important to choose.
Of course, in the manual there is information, but sometimes in the settings, auto calibration, if you choose engine with double banks, this will be fixed. But if you want the engine out of the list with 2 banks, you need to don't forget to set which injector is mounted on which bank. It's necessary to handle the adaptation and also the proper sequence of the gas injector steering. Yes, yes. So don't forget to use these settings in relation to engines with the banks. Here we have 4, but it's like a common that 6 or 8 cylinders with the V construction, they're having 2 banks. Yes, this is like a very important thing.
Yes, and the last information about those settings, this is information for the people, for the technician guys, for the place that you can install the gas system. Information for the technicians that they worked with our indirect injection controllers like QBox, QNext controllers. Here you have the injection sequence. Normally in the indirect injection, typical sequential injection, you have petrol injectors and gas injector 1-to-1, right? Here in the direct injection, it's not 1-to-1. So don't try. It's normal.
Yes, nothing is wrong. This is a typical settings in DPI engines, and it should work perfectly with the settings what is here default made it in the system. So don't care about this. If in a situation that you make a mess in the settings mechanically, then you can fix something. But normally it should be like any manual 1-to-1, and this settings is default. It's working with 4-cylinder engines. So just information for you. Nothing is wrong here.
Yes.
Okay. And let's follow the next informations. OBD is like in QBox and QMax family. Choose it on or off. For stock 400, it should be always on if you want to run with the adaptation and run with the settings. There is no proper way to set the proper maps and settings without the OBD connection. So it should be mandatory, yes, to connect the OBD. And if you choose auto system will choose automatically connection, what kind of it is, and then you don't need to change another one time these settings. And what we have here, there is a continuous code arising, and this continuous code arising is there is some cars that they are allowing to delete the error during the driving cycle. Yes, if this error is related with some evaporative systems or fuel level systems, we are allowing to add these errors to the auto clear list. Yes, and then if you choose to arise this error during driving, if you choose continuous arising, so even the car will be driving, engine will be running on, our ECU will try to arise this error. Yes, it will help to prevent appearing this error on the dashboard for the customer. That's why we add this functionality for your demand. Car info is atypical, nothing to add some informations. What we are still wanted from you is that if you will just choose the proper information here about the car, it's much more easier to help you in case of some issues will arise. Right. Yes, because we have some informations that are crucial here, the kind of the nozzles, what is the car engine, and so on. Yes, this is very useful for us. So if you will have additional 1 minute to refill, please do it from ourselves. And in relation to your questions from the last webinar related to first step of Stag 400, we want to show you the map and some information and how to edit the map, because default is 10,000 here, yes, RPM, and this is editable. What does it mean? It means that you can, using a right mouse button, if you put it here, watch again, and just press it, it automatically add a value related to RPM. Again, 3000, 3004, then, and he will approximate what you pressed it. Then, if you press a left button on it, you can put the value that you want, like for an example, 3200, yes, and then you have 3200. But if you make a mess here, you can delete some values, like put the pointer, press the shift and delete, and what will happening? It's disappearing one by one. Then you can add again using right mouse button, and this is the pool. And the same is happening with injection dose. You can add some values, see what's happening, you can add some values, and you can delete some values, but the combination of the keyboard is Alt and delete. Alt plus delete, yes, and it's deleting these values in relation to injection dose, yes, injection dose. You can edit also more than 15, it can be 20. Yes, from your experience, maximum usually is 15. But if you want, you can do it. So these two axes are editable fully, that you can choose whatever you want. And then, of course, we need to put it as information that you have one dimension graph compared to QBox or QNext. But it's much more easier to get. I will show you some example. If we have a OBD reader, a little bit big, but it is, okay. Come back to this window settings. What's happening if we raise up RPM? You asked how is the easiest way to modify this map. Yes, how we can do this? We can do this using a left mouse button. Cover the 4 points for an example, and we can press the plus button, yes, on the numeric keyboard, and what's happening now? Watch, the OBD is a little bit too rich. If you raise up the gas dosage, engine is working on petrol.
Okay, simulation.
So automatically, if we press plus button, see what's happening. It's the gas dosage is and calculation is just going up. So the gas dosage also is rising. 4.3 now. And of course, in this situation, we need to find out the proper gas dosage in relation to the proper mixture. Yes? Right. So short trim and the long trim should be close to the values compared to the petrol values. Yes. Right. If you make some like a base settings, you can use in all of the I think today all of the DPI engines, they are working very nice with auto adaptation ABD. Yes, there is no like in MPI engines, we are meeting some engines that they don't want to work perfectly with the auto adaptation in ABD, but in relation to DPI engines, 99% of the cars are working very nice. They don't have any problem with auto adaptation functionalities. And auto adaptation functionalities, it's very, I think 100% comparative to all the Q generation products.
Right.
It's nothing is new
With
here. Yes,
right.
You cannot find something untypical. Just easily. This is our information about what ECU our ECU is doing. This is result correction. This is target OBD map. Yes, it means that what our ECU is trying to do to have this collection on petrol. It means that the petrol value. Temperature of starting correcting the gas dosage, switching threshold, maximum gas ECU long trim, and collection during driving on petrol. This value will be written out here. Yes, and adaptation in open loop. Yes, so system will, as you see now, it's adding the value information on lambda, and then we'll calculate it. Then we'll calculate the gas dosage to adapt it to proper value. Yes, during open loops driving system. Just briefly information to adaptation. So after first step regulation, you can use auto adaptation, and then follow the next graphs is gas temperature correction, like in Q generation, reducer temperature correction, gas pressure correction, map correction to bank 1 in relation to auto adaptation that you can switch banks. Yes, it's 100% similar like in Q product family. Additional petrol portion, it's also the same like in Qbox, Qnext, and all other products, even GoFast. And the last thing what we want to show you is reduced pressure. What is this? See the orange line here?
Right.
And this orange line with these dots, it's a limitation of our emulated value of the pressure in voltage, yes? Fuel pressure in voltage. Sometimes, in some untypical situations when we are meeting some errors related to the pressure sensor or directly high fuel pressure in the system, you can help yourself by building this orange line to reach the limits of emulation. So we can just, this is Mazda code. I'm not sure that emulator in Mazda is allowing us to
yes,
to cutting. Okay. So we can reduce it. Yes, you see the petrol PCM was said
right.
that it's limited. So we can use this line to limit the fuel pressure that which one we are emulating to the petrol ECU. Yes, this value what we are sending, we can reduce it. Yes, so it helps to prevent in some situation when the default settings are not enough to handle the maximum emulated pressure. So we can use this line, we can modify it to in our decision, in our experiments in the car that the emulated pressure is too high. So we can using RPM value and voltage of the pressure in the fuel line, we can decide ourselves how it will be the limitation line of this map.
Sometimes after the installation, after calibration, when you are driving on gas, that error can occur. Just only example that sometimes you can find out and how to fix that problem is when you have the error in OBD, right, according to the high fuel pressure. And sometimes you will have the information that the value is too high, for example, right? So in that situation, the best way is to change to petrol, drive on petrol at the same conditions like you drive on gas, and check on the oscilloscope that is in our software.
Yes. What was the maximum?
What was the maximum value of the pressure of the fuel, right? This maximum value of the fuel pressure. So you can find out that, for example, in that car that you have, the maximum pressure was, just an example, 3 volts.
302 volts, yes.
302 volts.
Yeah.
But our emulator, after the auto calibration, set the value around 4 or something close to 4, right? So sometimes our system will emulate the pressure and send the information to the car ECU about the 4 volts, because it's the maximum value. And the ECU and his memory, we can say, has the information
the limitation, yes.
The limits
can be lower than our programmed value.
Yes,
right.
It's around 3 volts. So in that map, you can lower down the multiplier around, let's say, 3.3, 3.4.
And this allows us to don't having any issue with the pressure on the higher emulated values. Yes,
right.
That is helping you to reach out these limitations, yes, on it.
That's right.
Exactly. And today our time is going to be finished. I see the timings. In case of some additional questions related to Stag 400, of course, we are still open to help you using YouTube channel or Facebook channel. Of course, email, or you can call us using our department technical support. For the next time, probably because already we have some questions on the online, but we don't have the time now to get your answers. So we will do this, but using the channels that you send us the questions.
Right, and what is very important nowadays, or the channels that Marcin told you, email.
Yes, and stay at home. There is information that is not on camera, yeah. So, but you can say, stay at home. It's for your safety.
Right. So the better way is when you asked us using that electronic or the way
online channels.
Online channels.
Yes, yes. This is for your purpose.
It's not better nowadays face to face, but okay, we are open for you, and
yes.
Besides the problems that we have in whole the world, we would like to
stop the virus. Stay at home.
Right.
That's the information.
That's right. That's right. And but we do everything to make that training online, right?
Okay, so, and stay online. Watch the next date of the webinar. Of course, the topic will be related with questions and issues that you want to have it. And for today, thank you for your time. It was really nice to meet you again. Have a nice day, evening, night, or day.
Thank you very much.
Bye.
See you next time.